Hi students. Uh, Today I am going to show you how to design a spur gear in SolidWorks. So before you view this tutorial, I recommend you reading the section on spur gears in your textbook. Gear design is a very important field within mechanical engineering. There are, as you know, there are different types of gears such as spur gear, helical gear, bevel gear, spiral gear, worm gear, planetary, and rack and pinion. These are just few of them, uh, and each one of them have a special purpose. So it's important for us to just get a flavor of gear design. This course is not about gear design, but just to understand the the mathematics behind gear design. So you should read through this section here in from your book. There is a lot of math that goes into this thing, so you have to understand all of that. But I'm going to focus on a problem here, and so let's see. So after going through all this math, and we are going to need this, please read it and then come back and watch this tutorial. So here is a typical problem looks like. This is example 4.2 from your textbook. uh, Create the CAD model of a spur gear with R sub p, which is pitch circle radius of 60 millimeters. Phi is a pressure angle which is 20 degree, and capital N, the number of teeth on the gear, is 20. So we have these uh, three things that are given to us, and based on that we have to design an appropriate gear. So what I'm going to do is open the Excel file here, or in this case Google spreadsheet. So I'm going to open a Google spreadsheet, and let's I need to do some calculations before I can start working in SolidWorks. So the steps to design a spur gear based on this information are given right here. So the following steps summarize the calculations we need to create a gear model. So step number one, the input parameters we need are the pitch circle radius, which is 60 millimeters, the pressure angle phi, 20 degree, and the gear number of teeth n, 20. So far so good. So I'm gonna, maybe we can just type it here. uh, Let me see if I can make it a little bigger. So okay, so you can see my calculations. So RP is 60 millimeters. Okay. Next is let's see, phi, pressure angle phi, which is 20 degree, and n, the number of teeth on the gear, 20. N is equal to 20. So step number two, you need to calculate RB. So there are a bunch of circles when it comes to gear. So let me just quickly show you what circles we are talking about. So here they are. There is this base circle, there is this pitch circle, there is addendum circle, which is the topmost circle on the gear. Uh, just like the addendum circle, there is a dedendum circle on the other side of the pitch circle. Pitch circle is where the action happens. Where if they were circular plates instead of gears, they will touch each other on the pitch circle, right? Uh, in this case, the dedendum circle and base circle are the same, and then there is another circle that is not shown here, which is called the root circle. That is just provided for manufacturing clearance. And what is so special about gear design is the shape of a tooth, because that shape is not anything. If, if you just make any shape, then the gears will not mesh with each other appropriately. They will not work properly. So you have to be very careful about making the right shape. And what do I mean by right shape? That's where all the mathematics goes into getting that shape of the one tooth correctly. Once we get one side of the tooth, then maybe we can mirror it, right, and get then complete the one tooth. And once we complete one tooth, then we can create a circular array to create the 20 teeth for the gear. So there are different profiles that are suggested. The profile that we are looking at here, which we are going to work on, is called as involute profile. Uh, this profile of the gear tooth is involute profile. And what is an involute profile? If you wrap a thread around a coin and you keep one end of the thread fixed and unwrap the thread from other end, the path that thread will take as you are unwrapping it from the coin is called as involute profile, and that is the profile we need here so that the two gears mesh with each other properly. Okay, so that's enough information. You can read the rest of the information from the book, but for that, now we need to find out the radii of different circles. So once again, coming back to the instructions, we need to calculate RB using equation 4.5, which is the base circle radius, and then step number 3, which is to calculate root circle radius using equation 4.6. So I'm gonna look for equation 4.5 here. So that is RB is equal to RP times cosine of phi. So I need to uh, calculate that RB and then a root circle RR. So RB is equal to RP times cosine of phi. RP, which is this, times cosine of phi. So COS, that's good. I got the function cosine. But it says cosine of an angle provided in radians, and the angle that we have in is in degrees. So we will have to convert that angle into radians first and then take cosine of it. So anyway, I'm going to go ahead and use this function here, cosine. And in that function, I'm going to use a function called radians that converts angles from degrees to radians. So I'm going to select that and 60 degree, right? It's R, sorry, that's not the angle. Angle is the phi, pressure angle. Okay, so we need to change that, make it phi. Once again, let me take a look at this. Cosine of phi, yes, pressure angle, which is the 20 degree. Then I'm going to close that. So I converted that angle into radians, and then I have taken cosine of it and then multiplied that by the pitch circle radius. That's going to give me my base circle radius. So that's that 56.38. We can maybe round it to two decimal places. Okay, and then root circle radius. Root circle radius is it it's just the it provide root circle is provided for the manufacturing clearance on gear. Anything below the base circle of the gear, that profile below the base circle is not important. It's just provided for, it doesn't have to be a very specific profile because it is just there for the manufacturing clearance. So what can be my root circle radius? It can be approximate 0.98 times base circle radius or 0.96, whatever, in the context of the problem. But we are going to use this particular equation here. So that would be 0.98 times base circle radius. So that's that. Once again, we can convert it to two decimal places. So we have now radii of three circles. Each circle radius is given to you, base circle you calculated, and root circle you calculated. Okay, so far so good. Then we look at we already completed step number 2 and step number 3. Now we need to calculate something called as gear dedendum, which is d r, which is equal to pitch circle radius minus base circle radius. So I'm going to calculate that dedendum, pitch circle radius minus base circle radius. And why do we need that? So just to show you, so the dedendum is the here is shown here very nicely, is the distance between the pitch circle radius and the base circle radius. That distance between these two radii is dedendum. And why do we need to calculate that? Because then we can add that to the pitch circle radius, which is called as addendum here. Addendum and dedendum are same, so now we know dedendum, that means dedendum is same as addendum. We can add that distance to the pitch circle radius to get the radius of this, the outermost circle, which is called as addendum circle. So I'm gonna do that next. uh, let's go back to instructions. So after calculating dedendum, assuming that the addendum and dedendum are equal, calculate the addendum circle radius, which is rp plus a, or which is same as rp plus d. So Ra, which is addendum circle radius, the outermost circle on the gear, is equal to pitch circle radius plus dedendum. Okay, so that gave us that value. Then let's see. Next, we need to calculate the tooth angle alpha. That's another thing we need, tooth angle alpha. So let me go over that calculation. Alpha is equal to, uh, you can calculate, either calculate in radians or in degrees. If you want to calculate in radians, you take the pi radians divided by capital N, which is the number of teeth which is given in the problem statement. But I'm going to calculate in degrees. So alpha is equal to 180 degrees divided by number of teeth. So I'm going to write it down. Alpha is equal to 180 degrees divided by number of teeth is 20. So that's gonna give us 9 degrees. Okay, 9 degrees is the tooth angle. Okay, I believe now we have all the information. We yes, we do have all the information. uh, and we need to enter the involute parametric equation in CAD/CAM system to create that profile of the tooth. So I will get to that, but first, now that we know the radii of all the circles, why don't we go ahead and draw these circles in SolidWorks? And you can see here our the calculations are same as what are here. So we can either use these values or we can use the values that we have with us. uh, okay, so let's go to SolidWorks. Okay, I'm going to start a new part. Okay, I'm going to draw, sketch the 4 circles on the front plane. So sketch, and I'm going to draw 4 circles. Circle number 1, which can be your root circle. Circle number 2 is your base circle or also dedendum circle. Circle number 3 is the pitch circle, and circle number 4 is addendum circle. Okay, next you are going to provide the dimensions, smart dimension. Let's do that. And the way SolidWorks dimensions the circle is, probably we are going to need the diameters. What we have here is radii. So all we have to do is just multiply these numbers by 2 to get the respective diameters, right? This is pitch circle diameter. That's going to be base circle diameter. Similarly, with the root circle, you multiply that by 2, and addendum circle diameter. Okay, so we got, and you can do it up to 3 decimal places, or maybe uh, 2 decimal places. So this that's good. Now you can diameter. So these are the values that you want to put in there. So I'm gonna smart dimension. Let's start with the biggest circle here, right? That diameter is going to be 127.236. Okay. I guess I made one mistake that I would like to correct. I had This problem is in metric units, and my dimensions here are in IPS. So I gotta go ahead and change that, make it mmgs, and that brings you out of the sketch mode. So you're gonna go back into the sketch mode, right click, edit sketch, and you have to fix this dimension one more time. 127.236 millimeters. So that's good here. uh, and they will all adjust because I changed from inches to millimeters. That's why it's acting weird. But we'll go ahead and start dimensioning the other circle. So we did the outermost circle, then pitch circle. Next is pitch circle, and that's gonna be 120 millimeters. Next is base circle. So let's dimension that. That's 112.764. And the innermost circle now is 110.508. Again, those values are coming from here, right? So looking good. You can get them closer, so you can zoom on to the circles. I'll make it a little bigger here. Got to fix the dimensions, get them closer. Okay. Okay, I think that's good enough. So we have the uh, 4 circles. Next, what we would want to do is we want to create the tooth profile here, right? So I'm going to draw a construction line, center line from origin, a vertical center line for reference purposes. So that's good. That's the vertical center line. Now we can create the involute tooth profile from starting from the base circle, because as I said before, the profile of the gear tooth below base circle is not it doesn't have to be very specific, right? That is just for the manufacturing clearances. So we just need to worry about the profile of the tooth above the base circle. And then once we create the profile tooth, uh, if it comes out of the addendum circle, we can chop it. Whatever the profile of the tooth above the addendum circle is not important, we can chop it out, because we just need to go up to addendum circle, right? So now to get that involute profile, here enter the involute parametric equation given by equation 4.4 into CAD/CAM system. So we need to really use, that is, the equation driven curve. So what are the equations? They are given here. Mm, Basically we need to create, so going back to SolidWorks here, we need to create bunch of points, okay, that will lie on the involute profile, and then we can pass a spline passing through those points. But uh, d- getting those points means getting their x coordinate and y coordinate, and that's what these equations do here. X coordinate of any point is given by minus rb sine theta minus theta cosine theta, and y coordinate is given by rb times, and we know rb, base circle radius, rb times cosine theta plus theta sine theta. The only thing we don't know is angle theta, but that angle can be we can vary that angle, because at different angles we are going to get different x and y values, right? So we can vary that angle from 0 to some theta max, maybe 5 degrees, right? So for example, theta 0 will be this vertical line, the angle from the vertical line, that would be uh, 0, and so on and so forth, right? And as we go away from that line, our angle will increase. So that those are those equations. So we need to add those equations uh, in SolidWorks. So let's see here. So we need to draw a spline, and our spline is equation driven curve, okay. The equations that are given to us, they are parametric equations. I'm not going to go too much about parametric equations, but they are in terms of parameter theta. So that's why they are called parametric. So I'm going to change that to parametric. And the equations that we have, okay, the x coordinate is this minus rb times sine theta minus theta cos theta. So what we call here theta, in SolidWorks it is called as t. So we will do that. So minus rb, which is minus 56.382 times sine parenthesis sine t in parenthesis minus t times cosine t. And why, if you make mistakes, if you forget some multiplication or some parentheses, you will see red colors, that some text will show up in red color, so you know that there is a mistake. Okay, so y coordinate is given by rb times cosine theta plus theta sine theta. So let's type that. rb is 56.382 times parenthesis cosine cos in parenthesis t plus theta sine theta, or t sine t in parenthesis, and then we need to close the big parenthesis here. So looks good, and we want to vary theta between some angles 0 and some theta max, right? So let's put 0 as one limit, and 1 degree is, I think, more than enough. 1 degree, uh, because as I said, the profile of the tooth above the addendum circle that will be created will be, we need to chop that because we don't need that, right? So this angle 0 to 1 is sufficient, and SolidWorks will automatically do like 0, maybe 0.1 in increments, right? That the software takes care of that. And click OK. And here is what you got, the involute profile. And we really need to chop this portion here, yeah, but we'll worry about that afterwards. Now, and you can see it starts with the base circle, right? So next thing we need to do is, we need to create the profile of the tooth below base circle. It can be anything. So I'm going to make it a line here, like just draw a line. And what we need to do is make that line tangent to this arc of the profile that we created. So using my control key, press and hold, I'm going to select this line, and I'm going to select this arc and make them tangent. Okay. You have to be really zoomed onto that to see what's going on. So we have that. Then let's see. Then what I need to do is, this pitch circle pitch circle is really for reference purposes. It's, so we can make it like a construction line geometry, construction geometry. So I'm going to click on this pitch circle and make it for construction. Okay, because it's really not part of the final sketch. Now we need to draw a construction line passing through the intersection of this pitch circle and this gear tooth profile. So to do that, first I might want to draw a point there. So I'm going to select a point, and I'm going to put it somewhere here. Okay, I put the point there. And then I also want to make sure that that point is also on the pitch circle. So I'm going to select the point, control key, press and hold, and also select the pitch circle, and make these two things coincident. So by doing that, I am ensuring that the point is on the gear tooth profile as well as on the pitch circle. So we got that point there. Now uh, we need to draw a construction line from origin, and I'm gonna just draw a line like this. Okay, and that line should pass through the point that we created. So I'm going to select the line, control key, press and hold, and select that point there and make them coincident. So line is passing through that now. Okay, next thing is, we need another line, construction line. So I'm going to draw that another construction line from origin, something like this. Now we know that the gear tooth angle is, alpha angle is 9 degree. So we want to uh, do the half of that on this side of the gear tooth, and half of the angle would be on the other side of the gear tooth, right? The tooth angle, half of it, 4.5 degree, would be on this side, and 4.5 degree would be on the other hand side, right? So I'm gonna smart dimension and select this center line, and this, not the vertical line but this other center line, and that angle I want to make it 4.5 degrees. Okay, so basically that construction line is important from the point of view, when this gear tooth profile is complete, we can mirror it across this center line. Okay, so that's good. Now we gotta do some chopping. So I'm gonna do trim entities, trim to closest, and I'm going to chop the portion of this solid line that is below the root circle, this line here. That portion I'm going to chop. So that's good. Now also I need to chop the root circle portion that is between this portion here. I'm going to chop that. Okay, and there may be some piece here. You have to be very careful. You can see here, if I zoom in, I see some smaller piece there that also need to be chopped. Okay, so this straight line and this is the root circle, so that's good. Now, because we don't want any sharp edges, because that's not good. Mechanical stresses tend to get accumulated at the sharp corners, so we need to fillet that out. So I'm going to use fillet option. Fillet radius I want to 1 millimeter. It's a very short fillet there, 1 millimeter between this vertical line and this root circle. And you see, where is the fillet? You will see if you zoom out, this yellow thing is the fillet. Everything looks okay. I'm gonna click okay here. So far so good. Now we got this fillet. There is this part of this vertical line here, and then the involute profile of the gear tooth, all looking good. Also, you know that you don't need the the profile above the addendum circle, so you can chop that out as well. So trim entities, and you don't need this portion, you don't need that portion. Okay, so that's gone. And now we got a very good profile one side. This is involute profile. Then there is a small vertical line, not vertical but a small line which is tangent to that profile, and then a fillet. So things are looking real good. So we are ready to mirror this profile across this line here. But one thing you need to do, particularly on this exercise, and it's always good practice on all your projects, that you need to save your work all the time, because something happens to your computer, SolidWorks crashes, you will lose all the work. So I'm going to go ahead and save that. uh, I can put it in the default folder here. So I'm going to call it Spur gear. It's actually example, let's see, example 4.2 Spur gear. So that's what I'm going to do. I'm going to save it. Let me go ahead. Example 4.2 Spur gear. Okay, so I'm just going to save it in the local disk there. Okay, so things are looking good. It's time to mirror this. So I'm going to use mirror entities option, mirror entities. And which entities you want to mirror? We have to be very careful here. I want to mirror this fillet. I want to mirror this small piece of line here. Then I want to mirror this involute profile. So three things, right? And I want to, of course, create copy. Mirror about. I want to mirror them about this center line here. And you can see the preview. And that's looking good. It's, I got an error here or something. Mirroring fit splines on surface or equation curves create a mirror copy. I'm just gonna say okay here. Okay, so we got that. So one tooth of gear is complete. Now I guess we should go ahead and create a circular pattern, circular array. Create 20 more teeth by doing that. So let's see what I'm going to do is, first of all, this base circle, again we're not gonna need it in the final model, so maybe I select that and also make it for construction. Okay, anything that you don't need as a part of your sketch can be converted to construction line. Okay, then let's go ahead and create a circular pattern. So I'm going to click on the linear pattern, and the circular sketch pattern is hiding below that. So I'm going to click circular sketch pattern. That arc that was accidentally selected, I'm going to remove it. So entities to pattern. What entities do I want to pattern? Once again, we have to be very carefully selecting all the entities. There are 6 entities that we want to pattern. We want to pattern this fillet. We also want to pattern this small line. Then we want to pattern this involute profile. We also need to select this involute profile, then this small line here, and this fillet. So 6 things we want to pattern, right? How many teeth do we want? We want 20 teeth, and you can see the preview here. That's how it's gonna look. So looking good. I'm gonna click OK. Once again, save. It's very important to save because this is a difficult exercise. Next, I'm going to do some chopping, because we want to chop unnecessary portions, and we have to be very careful when we start chopping. So I'm going to use trim entities, and the portion of the root circle that is inside the tooth, we don't need that. So that is chopped very carefully. Start chopping. Don't chop the things that you shouldn't be. And in case of this gear, you can zoom onto it actually. So this is gonna be this chopped, this chopped. So that's clean. This, okay. I may have to undo few things here. Okay, and here I have to be careful what I'm chopping. Trim entities. Okay, looks like we got some problem here. Looks like it's not meeting there or something. I'm going to leave that portion. We can come back to that and start. Okay, so seems to have some issue. Okay, let's see. It's chopping the whole thing. Let's see what we can do. Maybe what I'm going to do is I'm going to undo a few times all the chopping that we did, maybe even the circular pattern. And yeah, here we are. uh, and what I will do is, first I will go ahead and chop this portion here. I'm going to chop this. Okay, I'm going to clean this, uh, and hopefully now we should be able to create a circular pattern. So let's go ahead and click on circular sketch pattern. Entities to pattern are 1, 2, 3, 4, 5, 6. Okay, and we want 20 of them. So we got them. Now let's see if we can chop this time. So trim entities, yeah, it's looking better. And I would like to chop on both sides to make sure everything is going in right direction. Yes, I think we are getting somewhere. I'm gonna continue my chopping very carefully, not chopping things that I shouldn't be chopping. Okay, we gotta be very careful. Let's see. And there is one more. Okay, I think we are good to go. Then we need to start chopping the addendum circle. I'm gonna click on save just in case, and continue to chop the addendum circle here very carefully. Don't chop things that you want to keep. Okay, here there are a bunch of lines, so we gotta be careful chopping every single thing. There's this piece of line. You gotta be very clean operation here. Okay, so chopping all the things carefully. Okay, so I guess we done a good job now. We chopped everything that should be chopped. Some lines, some circles are converted like pitch circle and base circle. We converted them into construction circles so they won't bother us. And looks like the sketch is complete at this time. So I'm gonna click on save button here and exit the sketch. Okay, now next is we need to uh, provide a thickness to this sketch. Okay, so we need to provide thickness to this sketch. So extrude and select the gear, the sketch, and the thickness is 25 millimeters. So I'm going to change that to 25 millimeters. And here is how our gear tooth gear looks like. We are not done yet. We need to do a couple of things. We need to make some cuts. So I'm going to choose the front face of the gear. Okay, extruded cut, and I'm gonna draw a circle from the origin up to this root circle, I believe. So we got that. The circle is complete. Then we need to exit the sketch, and we want to cut it, but in a certain way. We make it blind, make the depth of cut 10 millimeters. Okay. Another thing we need to do is check this box, flip side to cut. Okay. And we need to provide a taper angle here. Draft, we need to provide draft. We can do 60-degree draft. Okay. So once again, take a look at it. Blind cut, 10 millimeter depth of cut, flip side to cut, and 60-degree draft. Okay, and here is how the cut looks like. And same thing we want to do on the other side on this gear. So select the surface, extruded cut, draw the circle from origin up to the root circle, exit the sketch, blind 10 millimeters, flip side to cup, draft angle 60-degree, and okay. So that's how it looks like. It's all done, all good. I'm gonna put it in isometric orientation, and that is it. This is the end of the this particular example, designing a spur gear in SolidWorks. So with this, I will stop here. Thank you.